Huh. Okay. So, good morning, everyone. Welcome to Abhyas. So, as I told you when I was taking the crash course, that we will be doing very, very beautiful problems during Abhyas. And these lectures will be in English. Yeah, good evening, everyone. Some of you are always there actually in the crash course. We were also there. Very good. Huh? Rohit, Naved, I remember some of them. Huh? So, these lectures will be in English. And here we are going to do very, very good problems in Abhyas. Okay, na? I mean to say, some problems will be average problems, and some problems will be above average problems. Above average problems. Because in GATE, sometimes what happens, especially if you see metal forming and metrology, sometimes problem appears, we see that, oh, it is out of syllabus. Some people think it is not out of syllabus. Only thing is that problem is little difficult. So that kind of stuff we are going to see from here in these classes. Okay, na? Yeah, once again, good morning, everyone. Ashok, Yuvraj, Abhimanyu, everyone. Still, my throat is little off, so, but like 3-4 days, I'm really struggling with this throat. So today, first lecture is from the metal forming. These are my credentials. Some of you are basically repeating my classes, so you may be knowing. I'm gold medalist from Aligarh Muslim University. I'm Tech and PhD from IIT Delhi. 1.5 years I worked for engineering services, and I'm a researcher. I do research in material characterization and production engineering. And as per Scuba's data, I'm the top 5% researcher in the world as per data published in 2020. The result comes in 2021, 1 year later. So we are going to discuss problems, and we are assuming the motto of Abhyas batch is you have already done the theory. So don't get tense when some difficult problem appears. Don't get tense. And I request all of you to have the rough copy and the calculator pen along with you, because it is not a crash course that I am going to basically go teach theory. I'm not going to little bit theory I will teach linked to the problems, but mostly we will be practicing. So keep your calculator and rough ready and see the first problem. Yeah, Abhimanyu, can you ask the question after approximately 1.5 hours? Because yesterday lecture was recorded. Material science lecture was recorded. So, at least for half an hour, I want to get into metal forming. So, Abhimanyu, you asked this question because I announced in the Abhyas batch in material science that if you have any difficulty, you ask me tomorrow, I mean today. So just ask me this question after half an hour, okay na? After maybe 1 hour, okay na? But I want to cover certain things in metal forming. So first question is an easy one. First question is an easy one, and what I expect that you do solution along with me, okay? Very good, very good. In Telugu we call it chala bagundi. Okay, no, very good problems. Okay. A metal has a flow curve with strength coefficient 850 MPa, and the strength hardening exponent is 0.3. So we know that if you see stress strain curve, see in every exam including GATE, as the data is given to you, you either please record it or put it in some diagram, so that just by looking at the data, entire information is in front of you. Okay, so yeah, this is the one. This is the one. And अरे ये क्या हो रहा है, गलत सेलेक्ट हो गया. And in this region, sigma f is equals to k 850 epsilon raised to power 0.3 MPa. This data is given to you, na? Correct. Now, a tensile specimen of the metal with a gauge length 100 mm is stretched to a length of 157 mm. So now I will take the next page. You know, what is the gauge length? So here is a gauge length, Li. So Li is given as 100 mm. Li is given as 100 mm. And because we are applying the load in this direction, and the 100 mm becomes 157 mm. 100 mm becomes 157 mm. Okay, na? So this is the flow curve equation is given to you. A gauge length is 100 mm and it is stretched to 157 mm. Determine the, very good question. See, it's a really very beautiful question. Determine the flow stress at the new length. Determine the flow stress at the new length. That is, some of you are really champions. Okay, so what is, I will do that. And the average flow stress at the metal has been subjected to. I mean, I have loaded the material up to this point. Let us say point A. I have loaded the material up to point A. So here I have to find out what is sigma F, what is sigma F, and what is sigma Fm. So always, all of you are champions really. Oh, champions. And most of you are getting correct answer. Very good, very good. So, as I told you, in metal forming, always remember, see, you know, some of you are my, crash course student. I'm happy that you are in one go, you are getting the answer. I'm really very happy. But there are other students, they are either present today or they will see this video later on. For their benefit, I will solve it thoroughly. I told you these are average problems. After problem number 3, difficulty level will be more, so don't get tense. Okay, na? So this true strain in metal forming, true strain is always calculated the direction in which we are applying load. I hope you remember, in whether it's a wire drawing, extrusion, rolling, forging, sheet metal forming, epsilon is calculated the direction in which we are applying the load. So in this direction, the direction in which we are applying the load is length direction. So true strain is ln LF by Li. That's the true strain. Correct, that's the way we do it. So put the value, epsilon is nothing but ln 157 by 100. Epsilon will be 157 by 100. So if you solve this, it is 0.451. See, I have done calculation and Rohit has done calculation, both of us done calculation, but quite possible, we are human being. So sometime calculations, there will be an error. Let me know in the chat box if there is any error in the calculation, okay na? So sigma F is equals to K epsilon raised to power n, and we know that very well. So put everything here, 850.3, 850.451 raised to power 0.3, that is sigma F. And sigma Fm is nothing but K epsilon raised to power n over n plus 1. So most of you are getting the correct answer. Sigma F is 669. Most of you are getting correct answer. And sigma FF is in 514. Very good. These are the answer. These are the answer. So these are basically, you can say, average or slightly less than average, easy problem. So easy, na? Metal forming is easy, and all your fundamentals are clear. Very good, very good. Rohit Rajput, he's a captain. Captain and Virat. India-Pakistan match. It was really fantastic that day. Saurabh, again, all right. So Rohit was very happy that day. So it's an easy one, easy problem. Okay. In the beginning, purposefully, I have taken this problem so that there is an enthusiasm among all of you. Enthusiasm, okay? Na? Now let us gradually go one by one. Purposefully, we have designed the problems like this so that there are some mind muscles are strengthened. Yeah. So which of the following are advantages of characteristics of hot working relative to cold working? Now there are multiple things are given to you. Now options will be given. What are the statements? 1, 2, 3, 1, 2, 1, 5, 2, 6, like this. So out of these, how many statements are correct about hot forming? How many characteristics are for hot working? So what is hot working? When the operating temperature is more than 0.6 Tm and Tm is melting point in Kelvin. So some of the things that we discussed in theory, and some of you are already champions. Point number 1, accuracy will be less, because after metal forming, when the work comes to room temperature, it will shrink. So accuracy cannot be maintained. Now in hot working, there will be formation of oxides, and the formation of oxide will spoil the surface finish. Surface finish will be bad. In Telugu, we call it Bagledu. I don't think any Telugu person is here because I have not seen the name. By the name, I can catch. Now, by increasing the temperature, mean flow stresses decreases. I hope all of those who have studied in their BTech or somewhere, by increasing the temperature, curve goes like this. Correct, na? I hope everybody remembers. By increasing the temperature, curve goes downward direction. So by high temperature, lower will be the mean flow stresses. And what are the mean flow stresses? Mean flow stresses are the pressure at which the metal begins to flow and take the shape of die. Correct? Now you tell me, what are the characteristics of hot forming? Very good, Saurabh. Saurabh, very good, but thoda sa glitch hai isme. Fracture of the work part is less likely. Fracture of the work part. No, Yogesh, because PW, this instructed all the faculties. Abhyas will be in English. Crash course was in English. And for other regular batches, English batches are separate, English batches are separate. If you have any difficulty, then you let me know Telegram, personal message Telegram. I will voice record and send it to you. Because many English speaking people may be watching this, so please cooperate that. But it will be English only, okay? Na? There's a direction by PW for us, okay? Na? Okay, Yogesh, if you have any difficulty, write personal Telegram channel. For personal Telegram message, I will voice record and send it to you. Okay. Whether this statement is correct or not. See, during metal forming, yeah, you are 100% correct, Ashok. A is of correct statement. You know why? During metal forming, why crack appears? Due to work hardening. What is work hardening? Dislocations are piling up at the grain boundary. Excessive dislocation pile up leads to fracture. But in hot forming, because the temperature is above recrystallization temperature, new dislocations will die out. So possibility of fracture will be very less in hot forming. So first statement is 100% correct. All of you are correct. I am really very happy. Rohit, Ashok, very good, very good, very good. So first statement is 100% correct. Everybody understood now? Friction is reduced. No. See, metal cutting and metal forming, what we have studied. When the friction is high, na, there is something called sticking tendency. There is something called sticking. As the hot chips are flowing over the rake face, there is a sticking. Forging, there is a sticking. Why the sticking takes place? Because of friction. So how to reduce friction? Use molten glass. If there's a heavy reduction, molten glass as a lubricant. By using lubricant, I want to reduce friction. Are okay or no? So, wrong Gandhi. Okay, very good. Naveen Gupta, write me personally. Okay, na? Because I can help you in this because I'm a researcher. Naveen Gupta, write personal message to me. Okay. Increase strength and properties? No. Increase strength in properties will happen in cold working. Why? Because of work hardening. In hot working, work hardening will not happen. So C statement is also wrong. Are correct na? If you need further explanation, please write in the chat box. Now, yeah. Isotropic mechanical properties. This statement is partially correct. You know why? No real material can be isotropic. There will always be anisotropy. But at high temperature, anisotropy keeps on decreasing. So, at high temperature, you can say some of the materials will behave like an isotropic material. But please remember, in reality, no material will be isotropic. Some anisotropy will always be there in the material. Some anisotropy always there. Ashok Dahiya, in any metal forming operation, whether it's a wire drawing, extrusion, forging, rolling, sheet metal forming, if the reductions are low, we use vegetable oils, mineral oils, soap solution, that plastic, that kind of stuff. But when the percentage reduction is very high, we use molten glass, plastics, molybdenum disulfide. You're talking about, it's called molybdenum disulfide. It's a very, very popular lubricant in high temperature forming when the reduction is high. Very good, very good. All of you are doing very good, really. Now, less overall energy is required. Less overall energy is required. You can say it is correct. Why? Because at high temperature, mean flow stresses will be low. So overall energy requirement will be less in hot forming. Lower deformation forces required. That is also correct. Correct, we have discussed, na? More significant shape changes are possible. That is correct. You know why the more significant phase changes is possible? Because mean flow stresses are low. So wherever you want the metal to flow, it will flow. Okay, na? Now, strain rate sensitivity is reduced. You know, what is this? What is this? I will tell you that one. You know, this is, I think, new for some of you. I will tell you what is that one. This flow curve equation you have seen, na? I think there is a page. No, there is no page. So, our flow curve equation is sigma f is equals to k epsilon raised to power n. But this is incomplete flow curve equation. Complete flow curve equation is epsilon dot raised to power m. This is the complete flow curve equation. You know k, you know n. You know what is this m? What is this m? It is called sensitivity, strain rate sensitivity index. At room temperature, your Telegram channel, our PW Telegram channel is there, na? Mechanical, everybody should join. I request my backend team to put the link of Telegram channel in the chat box so that everybody can join. In that I'm active already. So at room temperature, value of m is almost 0. So that is the reason we say sigma f is equals to k epsilon raised to power n. But as the temperature increases, n value will decrease, m value will increase. So at high temperature, we cannot neglect m. At high temperature, we cannot neglect m. So this H is wrong. So that is answer. That is answer. Everybody is okay? Yeah, notes will be available. Answer Pasha, 100%. Whatever I'm doing now, I will generate PDF in your app. In your app, the same PDF will be available. Don't worry. But as the this course is going, you solve along with me. Okay, na? You solve along with me. Because by that you will learn. By that way you will learn. And questions are going to become tougher, I'm telling you. Soon questions are going to get tougher. Now, which of the following bulk deformation processes are involved in the production of nails for lumber? Yeah, lumber, what is a lumber? Are same carpentry work, the nail comes, tuck. 50 rupees, 100 rupees kg that comes, na? That is called lumber nails. Like tuck. All the different types of nail used in carpentry are called lumber nails. So how they are produced? Always remember, production method should be cheap. If the production method is expensive, cost of the product will increase. Okay, na? No, Ashok Dahiya. I will tell you. There is some confusion among the students about how to download it. I will inquire from my team and let you know tomorrow. I will let you know how to exactly to download this. All the notes are available. All the notes, whatever I covered in crash course and here will be available to all of you. But how to download, I will, because my team is there, I will ask them and let you know. Okay, na? So now, how the nails are produced? Certainly there is a wire drawing. There is a wire, so initially wire is drawn. And then exactly what we do now? After wire drawing, there is a shearing machine. That shearing machine cuts the outgoing wire into required size. Whatever size of nail you want, it shears off in that size. And on one side, there will be a small swedging kind of thing. The nail, na, that thing that goes inside the wood, swedging, duck, it goes duck. Swedging means from all the side, the material is being pressed. And on other side, it's upsetting. So it is hold like this, dum, so that the head comes. It's a upsetting. What is upsetting? What is the upset forging? Upsetting is a process of forging a portion of work, not the complete work. Upsetting is a forging process in which we forge a portion of work, not the complete work. So wire drawing, shear machine cut, other side swedging, dum, and hold this side, boom. So there will be head. Now see this, and now you see this. So extrusion, certainly extrusion is not there. Certainly extrusion, it's not an extrusion process. Okay, na? Flashless forging. Certainly, you know, when we use flash, when we want to forge complex geometries, we want our metal to flow in a certain directions. Accurate forging. But nails are not very accurate, na? So no flashes are being produced there in forging. Whatever, even if 10 or 20% extra, we don't care. Okay. Now, impression die forging, you can say it is correct, because in the head, sometimes there are impressions. So when we are forging, so this die impressions will appear on the head. You can say it's an impression die forging. So impression of the die, when we are making head, boom. So those impressions may appear. Suppose you see a screw. So that impression has to appear in the head. So Certainly rolling is not there. And upsetting. What is upsetting? Forging a portion of work, not the complete work. Forging a portion of work. Karmakar. Karmakar's comment is very, very important. So please, all students, those who are asking notes, please see in the chat box, Karmakar. His answers are there. And yeah, no, Ashok Dahiya. What is a flash? Suppose you want to have accurate forging. Suppose you want to have very accurate forging. So gutters are provided with the lower die. So upon forging, extra material flows into these gutters called flash. So when the metal is flowing, so it will fill up the intricate shapes that are there in the upper and lower die. And after forging, we cut the flash so that our forged product is accurate. So the purpose of flash is, to give direction to the metal flow. So all the intricate shapes in the upper as well as the lower die are filled. But here nail, we don't care. Even if 10% extra, 10% less, we don't care. It's a nail, no? It has to go through that set. No accuracy is required. Okay. So question number 3. Everyone is okay? Saurabh Yadav, ये भी है. देखो. Tomorrow I will try to give update. To be frank with you, we have a backend team. They looks after all these things. And if you want, because that's the basically motto, we should not share all these things in the Telegram channel. Everything is available on the app. So I will take some tutorial from my backend team and I will tell you, okay, na, how exactly DPP and notes you can download. Okay, now the difficulty increases slightly. Okay, na? Now the difficulty is slightly more. Up to question number 3, it was an easy cake, na? It was an easy cake. Now you see. Okay. Determine the shape factor. Now, when the shape factor will come into picture, why our team, they have included the questions on the shape factor. Why they have included the questions on the shape factor? Because recently in GATE, there was some idea they have touched about the shape factor. Okay, na? I will give you some background. Whatever is the forging operation, whatever is the forming operation, wire drawing, extrusion, forging, and then rolling, sheet metal forming. There are different methods. Please hear, everybody should hear carefully now. There are different methods. To find out the forming load. First method is upper bound theorem. Next is a lower bound theorem. Third one is slab analysis. Next is a slip line field theory. Slip line field theory. And finally, the empirical formulas given by Johnson. See, in mechanical gate exam, already you will find questions on the Johnson's and slab analysis. In mechanical exam, a lot of questions are there in Johnson's and the slab analysis. Recently, in gate mechanical, they have touched the idea about the shape factor, but in PI gate, they are continuously asking about this shape factor. Shape factor idea comes in upper bound theorem. Once again, you cannot mix the two theories. Either you follow only upper bound, or you follow only slab analysis, or you follow only Johnson's equation. Okay, so you cannot mix the two theories. No, upper bound theorem, you know what it says? Whatever forging load you are calculating, your actual load will be less than that. So whatever forging load you are calculating in upper bound theorem, it's the shape factor. Let us say shape factor is kx. Shape factor is kx into sigma naught into area. Area along which the deformation is taking place, sigma naught into kx. That will be your forming. I'm saying forming. Forming can be anything. All right. So now, at least for 15-20 minutes, I want to dwell on this. Dwell on what is the shape factor, how to calculate the shape factor. See, I am there in the Naveen Gupta. I am there, Dr. Swadesh Singh. My name is Dr. Swadesh Singh. You search there. I am there actually in the Telegram channel. The Telegram channel name is PW Mechanical Discussion. Our backend, because it's Diwali holiday, I mean, some of our backend team is not active, I think, today, because generally they are always active. So if they at all they are hearing me, please put that Telegram link channel in the chat box so that students are aware, and I'm there in that group so that they can ask any question. Yeah, Ashok Dahiya, you are correct. It is always a final area. For example, forging calculations are done always on the final dimension of billet. That we will discuss later on. So now you have to calculate the shape factor for 4 geometries. One is a rectangular ball, second is a tube, and there is a channel, and this is a geometry. So what I'm going to do, I'm going to solve 1, 2, 3. This I will give you home exercise. I will give you answers, but this will be the home exercise. Okay, na? And as per the upper bound theorem, this is the formula for shape factor. It will be same. This is the formula of shape factor, and it will be same. Okay. CC is the perimeter for equivalent circle. So whatever area you are extruding via drawing, same area if you put it as a circle. So perimeter of equivalent circle. CX is the perimeter of given geometry. Recently, in the gate mechanical, this question was there. You know what kind of question? Calculate the extrusion ratio. Some geometry was given. Initial area or final area. Wherever this concept is given, it is taken from some book. So wherever the gate question appeared, below that exactly this concept was there. Same problem. So that is the reason I am covering this year for gate 2023 and let us say probably 24. So now my first geometry is 60 by 20 rectangle. My first geometry is 60 by 20 rectangle. 60 by 20 rectangle. So this is the geometry. I have to calculate the shape factor for that. So now, what is the area? Area of geometry? 60 into 20 comes out to be 1200 millimeter square. So see, the way I'm going to go, please see. Just Naved, please look at it, because you are a champion. I know that you are a champion. Rohit and you, that 3-4 champions are there, I know that. And I wish God that you crack very good rank. And I'm hoping not only 2 of you, but I can remember 6 or 7 names. If your mind is good at the time of exam, you are a stuff of top 100. I'm not joking. Some of you are there in my crash course, na? 7 of you, at least 7, 8 of you, you are a stuff. So, but What you have to do? Head cool. How become head cool? I told you the Gyan. In the morning, remember God. Don't have any negative feeling about others. God will help you. Okay, na? All right. Now, what is the parameter? 60 plus 20 plus 60 plus 20. So 2 into 80. Is that okay with everyone? Is that okay with everyone? Check whether it is okay. So this is Cx. Cx is the perimeter of the given geometry. Now, given geometry area, I'm talking about this area now. This area equate with a circle. Equate with a circle. This area and this area are same. So 1200 is equals to, let us say, r is the radius, pi r square. 1200 is equals to pi r square. So calculate the area. You calculate r, and once you calculate r, cc is perimeter of the equivalent circle. So what is the perimeter? 2 pi r. Once you calculate r, calculate 2 cc. Put cx and cc here. Find out the shape factor kx. Do it. Please do it. Oh my God, Ashok Dahiya. Oh my God, you are too quick. But anyway, there are a lot of champions. There are a lot of champions. Okay, na? Give me the kx value. Shape factor. Give me the shape factor value, please. All the calculations are in front of you. Give me the value of shape factor. All the calculations are in front of you. Once again, the Cx is perimeter of the geometry given to you. Perimeter of the geometry given to you. Geometry area equate to a circle area. So, given circle perimeter is cc. Put Cx and cc in the formula. Try to mug up this formula. Once again, this formula will be from upper bound theorem. Oh, very good. Abhimanyu. Karmakar, yeah, you are also one of them. Actually, I was talking. I was thinking 7, 8 of you. Eh? Riyaz Hussain, Razia Sultan. Yeah, 1.016. Very good, very good. Yeah. 1.016 is the shape factor. See, in exam, when coefficient of friction is not given to you and shape factor is given to you, then the forming load will be kx multiplied by sigma naught and the area. Please remember that. It's upper bound theorem tells you about. Very good, very good. In Telugu we call it Chala Bagundi. All of you are getting the answer. Okay, very good. Go to the second geometry. Circle 50 and 2.5. Case 2. This is the geometry. This is the 2.5 and outside diameter is 50. So let us say D1 is 50, D2 2.5 and 2.5, so it is around 45. So what is this area? What is this area? Area will be pi by 4 50 square minus 45 square and is equals to pi r square, equivalent circle area. Okay, na? And what will be the perimeter? Cx, this plus inner one, pi d 2 pi r, na, plus pi d. It's a total perimeter, na? Outside and inside will also be included. And cc will be nothing but 2 pi r. Once you calculate r from here and then calculate kx, give me the answer. Give me the answer for the second one. Give me the answer for the second one. Give me the answer for the second one. Very good, very good. Valley of Flowers. Still I remember your name, Valley of Flowers. Naveed, I think there is some. Yeah, you are talking about the first question. Yeah, good. The B part. What is the answer? B part. Quickly. It's a very good practice because gate is nearby. Not too many days are there. I don't want to dwell too much on these problems. So that's the reason you should be serious in the Abhyas. You should be serious during the Abhyas. So you don't have to again revise the whole thing. You don't have to revise the whole thing again. Very good. Very good. Ashok Dahiya. Abhimanyu. Very good. Very good. Very good. See, some of you, I would like to clarify. I have 7 lectures in Abhyas. First was material science. Second and third lecture was on forming. First lecture of forming, I am discussing wire drawing, extrusion and forging and general thing. Second lecture will be on rolling and sheet metal forming. Lecture number 4 and 5 are on metrology questions we will do. 6th, we will do welding, resistance welding and all that. And the 7th, we will do automation. We will do automation. Yeah, you are correct. Abhimanyu, this relationship, please remember. It is not very difficult to remember this relationship. It's not very difficult. So please remember this equation. Answer is correct. 1.52. 1.52 is the correct shift factor. You please remember this thing. I am not requesting you to remember too many things. In metal forming, our proof approach takes care of everything. Okay? Very good. Very good. Very good. Now, can you see this geometry? (60, 30). This geometry. It's a channel like this. And this is 60. And I think this is 5. Everywhere 5, and this is 30. Thickness everywhere 5. And this is 30. So this is the area. So this will be 50, na? 5 on this side, 5 on this side. So area will be nothing but 50 into 5. 50 into 5 is this area plus 2 times these two areas are the same. 30 into 5. Correct, na? 30 into 5. And now, what is the perimeter? What is the perimeter? Cx. See, 60 plus 30 plus 30. 60 plus 30 plus 30. 60, 30, 30. 5, 5, 5, 5. This is 50. And this will be how much? Tell me. 30 minus 5 is 25. So plus 25 plus 50 plus 25. Correct, na? See, 30, 30, 60. 5, 5, 25, 25 and 50. Got it? Cx. Equate the area. Area is equals to pi r square. And Cc is nothing but 2 pi r. If you put it here, can you tell me what is the Kx? Quickly do it. Oh, very quick. Karmakar, very quick. Abhimanyu, very quick. Very quick. So this speed is required in gate. This speed is required in gate. No, Suraj. There is some error in the calculation. There is some error in the calculation. Some error in the calculation. Answer will be 1.17. Answer will be 1.17. That's the correct answer. 1.17 is the correct answer. 1.17 is the correct answer. So, you know why I'm discussing this multiple problems? So that the concept of shift factor goes directly to your mind. Concept of shift factor directly goes to your mind. But remember one thing. Because in crash course I told you analysis of wire drawing and extrusion are same. Analysis of wire drawing and extrusion are same. Forging and rolling is different. Suppose the question is asking about the upper bound theorem. Shape factor formulas will be different. Shape factor formulas will be different. But final outcome will be same. Load will be nothing but shape factor into sigma into A. This will be same, but depending upon which process you are dealing with, the kx value will be different. And generally, my experience with the gate mechanical is, the formula will be given to you. Even in the last 2 years, we are seeing the metal forming. Our classical formula, sigma d is equals to sigma naught 1 plus v by v 1 minus a f by I. That formula was also given to you. So my personal experience is that with the gate, especially mechanical, not PI, mechanical, that if you have to use a shape factor, the shape factor formula will be given to you. But you should know how to incorporate. Abhishek, automation part 2 is already uploaded. Just check the library. Because that day there was a major issue in Hyderabad in internet, Deepavali day. So after half an hour, net was gone. So automation part 2 in crash course is already there in the playlist, bottom 18th number. So please look at it. Yesterday it was uploaded. Okay, na? Ha, very good, Naved is following up that one. Okay. So in extrusion and wire drawing, how the shape factor calculations are done. So these questions I have discussed based on that. Okay, na? I am giving you the final answer for this. You do it at home because I want to move forward with many problems. For this, the answer will be 1.62. It will be 1.62 is the answer for this geometry. Anyway, PDF will be given to you. So when you are at home, please solve this. Answer should come out to be 1.62. Okay. Now, after shape factor, let us get into one numerical. Very good numerical. Read it. We will do together. Please read the problem. A direct extrusion operation produces the cross section shown from a brass billet whose diameter is 125 and length is 350. It is a very new problem. Please be careful. Solve with the cool head. In the gate, although some of you are champions, I don't know whether all the champions are present here or no. One person champion is from Kashmir. But all the champions, please listen carefully. While solving final exam gate problem, have the head cool. Read the data properly. Present the data in a rough so that all the data is handy to you. It's a very good problem. Very good new problem. Okay. So I'm writing the data at one place. a direct extrusion operation. So my extrusion operation is like this. Direct extrusion operation means we are applying the pressure from this side. Produces the cross section shown from the brass billet. From a brass billet whose diameter is 125 mm. This is 125 mm, and the diameter is length is 350 mm. Length is 350 mm. The flow curve parameters of the brass are K is 700 MPa and N is 0.35. Epsilon is to power 0.35 MPa. So that flow curve equation is given to you, okay na? And at the exit there is a cross section area. It's not circular. Exactly na same problem. One bit appeared last year gate. One bit, okay na? But once again, see, there are a lot of things in this problem. I want you to read this problem carefully. Very good, Nave. That's what I want to tell you. Screws of your mind will open, okay na? Now, but once again, I want you to see this problem very, very carefully because there are many, many new things in this problem, okay na? So, have the head cool and drink some water. Okay. Johnson's equation. There are 5 methods to calculate force. Empirical formulas were given by Johnson. So what is the Johnson formula? Sigma D is equals to sigma naught A plus B ln R. R is the extrusion ratio. Extrusion ratio. Extrusion ratio, and it is the initial area over final area, and A and B are Johnson's constant. Johnson and Johnson powder na bachchon ka powder, no, that's not Johnson. A is equals to 0.7, B is equals to 1.4. So these values are given. Determine the extrusion ratio and shape factor. These are direct question. There is no matha pachi in this. So extrusion ratio and the shape factor, 60 versus 20. 60 versus 20. I hope some of you have given the last year gate, na? So one bit was last year only, na? Other bits are new bits, okay? So extrusion ratio is initial area over the final area. So initial area can be calculated by this cross section, and final area is a hill. Final area is this area, AF, and AI can be calculated from here. And to calculate the shape factor, unit CX. CX is 60 plus 20. Perimeter is 160 mm, and the area is 60 into 20, equivalent to pi r square. So CC will be nothing but 2 pi r. Now, can you give me these two values? Shape factor and extrusion ratio. This is the easy thing. Yeah, very good, very good. I want answer from you. Extrusion ratio, everybody given the correct value, 10.23. 10.23, very good. And what is the shape factor? It's also easy bit. It's also easy bit. Yeah, Abhimanyu Kumar Singh, you are intelligent. You know how? Array, sometime back only we solved, na? Previous problem. Array, previous problem, na? Previous problem. So 1.016. Array, last problem also we have taken, na? Last problem only we have taken this, na? This geometry. Okay, very good, very good, very good. Very good. In Telugu we call chala bagundi, means very good. Chala bagundi. Okay. Very good, very good. So these two terms were easy. Space is there. Yeah, space is there. Now, see the next problem. The force required to drive the ram forward during the extrusion at the point in the process when the billet length remaining in the container is 300 mm. You have to calculate the force. You have to calculate the force. To calculate force, we need to calculate sigma d is equals to sigma naught A plus B ln R. And the sigma naught is nothing but mean flow stress. N value is given, K value is given. And I told you that true strains are calculated the direction in which you are applying the load. Please remember this thumb rule in solving any problem of metal forming, the forging, wire drawing, extrusion, sheet metal forming, because you will be using the flow curve equation very frequently. True strains are calculated the direction in which you are applying the load. So please don't forget these things, okay na? So epsilon is nothing but ln LF by Li. That's the way we do it, na? In the plastic deformation, I mean the work hardening region, volume will be constant. Volume will not be constant in the elastic region. Volume will not be constant in the elastic region and after UTS. But in the work hardening region, volume will be constant. So can I say AILI is equals to AF LF? Can I do that? So I have to calculate LF by Li is nothing but AI by AF, and it is nothing but the R extrusion ratio. So calculate epsilon, put it here, sigma naught. I need the value of sigma d. Can you give me the value of sigma d? Can you give me the value of sigma d? Very good, very good. Suraj Pandit. A little bit off is coming. Once again, Akhare Dhyanesh, check the channel. It is uploaded yesterday. Tripathi. Yeah, almost correct. Tripathi is almost correct. This is 696 MPa. This is the 696 MPa. 696 MPa. Check. See whether everything is okay. Whether everything is okay. Whether everything is okay. And then sigma d, A and V value or everything is given. Calculate sigma d. I want the answer of sigma d. Sigma d. Only the AP Tripathi answer I am able to see, and his answer is almost correct. See, myself and Rohit calculated these things, but quite possible our answer may have some error because we are faculties. Yeah. Rohit Rajput, your and mine answer is matching. Oh, Abhimanyu, you calculated the no, wait for some time. Sigma d is 2755. 2755 MPa. That is my answer. That is my answer. Some of you, no, how it can be different? See, sigma naught is there, A, B value, R, all these things, na? So, some of the answers, yeah, Vishal Kushwaha, Suraj Pandit, yeah, now answer is correct, Suraj Pandit, Arjun Pandit. Now, Arjun Pandit's answer is correct. Suraj Pandit means Arjun Pandit. I hope you remember Arjun Pandit. But this particular question, each and every bit, I want you to learn. Each and every bit, I want you to learn. Now, whether it's okay, little bit off comes here and there. Little bit off comes here and there. It's okay. Okay. Now, because as I'm waiting for some time, now force will be sigma d into the area at which you are applying the pressure. Sigma, it's a forward extrusion, na? So in the entire area I am applying the pressure. So what is the area? Initial area, pi by 4, 125 square. This is the area at which you are applying the pressure sigma d. This is the area at which you are applying the pressure sigma d. So sigma d into pi by 4 di square. Calculate in meganewtons. In the backward extrusion, our area will be pi by 4 di square minus df square. In extrusion, sigma d should be multiplied with the area at which you are applying the pressure. The area at which you are applying the pressure. So in the forward extrusion, pi by 4 di square. Backward extrusion, pi by 4 di square minus df square. Please don't do mistake. Basically, many students do this blunder actually here. Now the answers are coming correct for most of you. At least it is matching with me, to be frank with you. 33.8 meganewton for me. 33.8 meganewton for me. I think most of you are getting the same answer as me. Yeah. Vishal Kushwaha. Ashok. No, yeah, initial area correct. Kamra Kar. Saurav Yadav, AP Tripathi, Pavan. Now everybody is getting the Abhimanyu. Abhimanyu, very beautiful name. Huh? That is the way Team Drona was announced before its launch. That अभी किसी अभिमन्यु को चक्रव्यूह में नहीं फंसने देगा. तो you are Abhimanyu. If you see the teaser, na, that's the way it is announced. अब किसी अभिमन्यु को चक्रव्यूह में नहीं फंसने देगा. चलो जो भी है. अब इसका last, you see the last problem. See the last problem. It's a very beautiful problem, really. Okay. Because of last problem only, I wanted you to see this problem very carefully. Because of the last bit only, I wanted you to see this problem very, very carefully. Space hai. Very good. Very good. See, what is the last bit? The length of extruded section at the end. Please read very, very carefully. I think you remember, na? Okay, Akshay. I think you are cooperating me very well because my throat is a little out last 3-4 days. And during Deepavali, a lot of sweets, cold things are taken, so it's not improving. So I hope in 1 or 2 days it will be better. Okay. The length of extruded section at the end of operation, you have to find out what is LF. You have to find out what is LF. If the volume of the butt left in the container is 6 lakhs millimeter cube, I want to teach you something. I want to teach you something. Everybody should see on the board. Without fail, everybody should see on the board. Suppose this is a die. With the help of this question, I'm teaching you one very, very important fundamental. Please look at the board very, very carefully. In fluid mechanics, there are something called streamlines and potential lines. Streamlines and potential lines. Very important theoretical point I am making here. At any point of time, flow is tangential to the streamlines and normal to the potential lines. We know that or no? At any point of time, flow is tangential to the streamlines and normal to the potential lines. Similarly, in the metal flow, there are slip lines. There are slip lines in the metal flow. There are two types of slip lines. One is a alpha slip line, another is a beta slip line. One is a alpha slip line, another is a beta slip line. Similar to exactly that thing. At any point of time, flow will be tangential to the alpha line and normal to the beta line. Tangential to the alpha line and normal to the beta line. So now in extrusion, because the way metal is flowing, if I draw alpha lines will be like this. See? Okay, all right, na? So these are the slip lines in the extrusion process. Reason is, I hope everybody is hearing very carefully. Reason is, semi-die angles in case of extrusion are quite high. Semi-die angle in case of extrusions are quite high. So what happens? There will be regions like this. There will be regions like this in which slip lines are not appearing. There will be regions in which the slip lines are not appearing. These regions are called dead metal zones. These regions are called dead metal zones. So, in fact, when the entire extrusion gets completed, some metal will remain in the system. This metal, what is this metal? Dead metal zone. So question is asking about the dead metal zone, and that volume is given to you, millimeter cube. These dead metal zones, I hope you are continuing to hear carefully. These dead metal zones creates obstacles in the metal flow. What is the metal flow? Along the slip line. So the dead metal zones creates obstacles in the flow. So it increases the load requirement. In upper bound theorem, shape factor considers this dead metal zone. But in the slipline field theory, not slipline, for the slab analysis, because we say slab analysis gate is very important. In the slab analysis, we do not consider these dead metal zones in the calculation. But upper bound theorem considers calculation of shape factor. Okay, na? So even when the extrusion process is complete, some volume of material will remain. Okay, na? Now read the question. So because it was a bit given to you, so I wanted to extend the bit little bit so that I can teach you the concept. Okay. So now, what is the initial volume? This is the initial volume, 350 and 125. So initial volume, pi by 4, 350. How much it is? 125 and 350. 125 is square into 350. That is the initial volume. Okay. So final volume is nothing but initial volume minus this one, because that volume of material remains. Now final volume is nothing but cross section area into LF, and the cross section area, what is the cross section area? 60 by 20. This is 60 by 20. Can you tell me what is LF? Do it now. But understood what is dead metal zone? Very good, very good. Yeah, Naved, you are 100% correct. You are 100% correct. Because that, as per Kalpakajian is a very beautiful book of manufacturing. Kalpakajian says that these dead metal zones not only creates obstacles in the metal flow, but also start moving in the backward direction. So more energy is required. More energy is required to push the metal forward. Increases the extrusion load. Increases the extrusion load. Okay. सारथी हम सारथी है भाई आपके आपको दोड़ा है, दोड़ा was opposite to सारथी है. You know, very good. You know, I like that comment really very much, Rahul. Very good. LF. I like the Rahul's comment really. It is 3079 millimeter. Or you can say 3.079 meter. Very good. That is the answer. That is the answer. I will again repeat. I am discussing forging, rolling, and forging, extrusion, and wire drawing today. Tomorrow I will be discussing rolling and sheet metal forming. Tomorrow's topic will be rolling and sheet metal forming. Okay. Very good. Very good. So it's an easy one. क्वेश्चन की फोटो कहाँ भेजें? अरे नहीं राहुल, अरे क्या बात कर रहे हैं यार, मेरे पास बहुत सारे ना. अरे भाई जो टेलीग्राम, आई एम स्पीकिंग हिंदी बिकॉज राहुल आई नो ही इज आई थिंक आवर क्रैश कोर्स स्टूडेंट, आई नो हिम. Question photo, you put it in the telegram. I am also there. I think there is one Rohit, the person who basically helping us to develop these questions. He is also available. So telegram, just send the photo to me. Whenever I free, I will voice record it and send it to you. Okay, na? If it is required. Don't worry. Don't worry. Acha, you are already paid batch. Paid batch, there is lot of support is there in that. because my classes will be in January, so I will ask. All right. Okay, very good. Next question. Next question. Very good question. Bar stock of initial diameter 90 mm. Our backend team, I think you are present now. Can you give the Telegram channel name in the, a Telegram link in the chat box? Because some students are asking. Bar stock of initial diameter 90 mm is drawn with a draft of 15 mm. So let us write the data as I told you before. Initial diameter, this is a solution. Initial diameter is 90 mm. Draft is 15 mm. Draft is 15 mm. 15 mm. The draw die has an entrance angle of 18 degree. Now, semi die angle is given as 18 degree, or okay, na? Entrance angle is 18 degree. I am just compiling the data. Then we will discuss. Now, coefficient of friction, mu is 0.08. Mu is 0.08. Okay. Now, the metal behaves as a perfectly plastic material. You know what is the meaning of perfectly plastic material? Stress strain is like this. Elastic, perfectly plastic, and the yield strength is given 105 MPa. 105 MPa. So when the material is behaving elastic plastic, so same thing can be taken as sigma naught. Same thing can be taken as sigma naught. Okay, na? So now determine the area reduction. Determine the area reduction. So draft is given to you. You read the problem once so that all of you are you read the problem once so that you are confident. You read the problem once so that you are confident. Read the problem. Now draft is given to you. So draft means this is the given data. This is the given data. So final diameter will be nothing but initial diameter minus draft. Generally, this draft is the word we use. Draft is the word we use in case of rolling, but here also we can use it. Okay, na? So it is 90 minus 15 is equals to 75 mm. Initial diameter, final diameter. So what is the first question? Area reduction. Area reduction, or it is also called percentage reduction. Area reduction is also called percentage reduction. It is initial area minus final area over initial area into 100. You know the diameter, AIAFF. Can you calculate the percentage reduction in area? Quickly solve. Can you solve? Can you solve? Can you solve, please? What is the area reduction? Yeah. Very good, very good. Very good. Very good. Rahul, I think we will discuss personally. I think you discontinue writing on the chat box. 30.55%. 30.55%. 30.55%. Area reduction. So what was the new concept in this problem? Generally people think that draft is meant only for rolling. That is not correct. Draft also meant for extrusion and rolling, extrusion and wire drawing as well. So it was a wrong concept that only a draft means only rolling. So that's what I wanted to teach you here. Now second is draw stresses. Draw stresses. Slab analysis. Slab analysis. Sigma D is equals to sigma naught 1 plus B by B 1 minus AF by AI raised to power B. Some students say, sir, we have to remember this one because 2-3 times problem appeared in GATE last couple of years and this formula was given. But I suggest to all of you, please remember, mug up this formula. If you go by proof, it is easy to remember. But in the crash course, and here we are not going to do the proof. So my recommendation, you remember this thing. Sigma naught you know very well. Sigma naught is the same thing. And the B is equals to mu cot alpha. Mu is given, alpha is given. Put everything here, you find out the draw stress sigma D. If it is an extrusion, then what I told you, that it will be, if it is an extrusion, because the boundary condition changes, the same formula becomes sigma naught 1 plus B by B. This factor comes here and the reverse. AI by AF raised to power B minus 1. You know why the change happens? Because the position of boundary condition changes. So tell me what is sigma D. Quickly do it. What is sigma D? Now, Abhimanyu, I think you have made some mistakes because that is not the answer I am getting. Quite possible I may do some mistakes. Quite possible. I have calculation mistake, but you know that is not my answer. B, A, F and AI, you know. I want sigma D is also called draw stress. Yeah. Ashok Dahiya, that is my answer. Vishal Kushwaha, that is my answer. Naved, very good question, Naved. When we proof it, when we do the proof, suppose mu is equals to 0. In the GATE question, when the coefficient of friction is not given to you, the proof comes sigma D is equals to sigma naught ln AI by AF. This formula you have to remember. When mu is equals to 0, the same thing boils down into this. Once again, when coefficient of friction is not given to you in the problem, our sigma D formula boils down into this. So when I do all these proofs, I will prove you these things. Okay, na? Very good question, and you have to remember these things. Very good question, and you have to remember these things. So sigma D, my sigma D is coming 45.65. 45.6 MPa. Very good. Most of you are getting the same thing. Pavan, Karmakar, Rohit, Rajput. No. It is given. It is not die angle. It is an entrance angle. Muhammad Naved. Acha. Okay, Muhammad Naved. Now it's clear enough for you. If mu is equals to 0, the same formula will boil down into this. So as of for 23, you remember this thing. And Abhimanyu Kumar Singh, the entrance angle is given to you. If you read the problem carefully, it's a very good doubt, Abhimanyu. Entrance angle. Suppose here it is clearly mentioned die angle. Then it is a 2 alpha. Entrance angle is always like this angle, dry entrance angle, because the entry of this material into the die. Okay, very good. Now, draw force required. Draw force required. Draw force will be nothing but sigma d. See, in the wire drawing operation, wire is coming from this side. Wire is coming from this side. So we are pulling the material from the front. Na? We are pulling the material from the front. So AF, sigma d will be AF into AF. In extrusion, since we are pushing the material from the back, so then the EI will come. But in the wire drawing, because we are pulling the material from the front, so AF will come. Is that okay with all of you? What is the force now? What is the force now? Abhimanyu. What is the force now? Please let me know what is the force now, because I have some answer and that should match, because till now all answers are matching for this particular problem. So that answer should also match. Yeah. Some of you are already getting the answer. Some of you are already getting the answer. Some of you are already getting the answer. And the answer is 201.6 kilonewton. 201.6 kilonewton. Kushwaha, you are also getting. Pavan Dwivedi, very good. Muhammad Naved, very good, very good. Anyway, just I want to do some correction. Of course, for examination, it is not important. Please remember, because I want all of you to be champion everywhere. Okay, so you shouldn't do any technical mistake. This will be small, this will be capital. For examination, it is not a matter. But suppose you go to job and all that, please remember, this will be small, this will be capital. For examination, it is not important. Okay, na? Very good, very good, very good. Jatin Sharma, also. Dahiya, very good. And the last bit of this question is, the power to perform the operation if the exit velocity is 1 meters per minute. If this exit velocity is 1 meters per minute, what is the power? It's very easy. So power is nothing but force into velocity. So 201.6 into 10 raised to power 3 Newton, na? Multiplied by V2, 1 divided by 60. Is that okay with all of you? 1 divided by 60, because I have put it in the second. Meter, 60 minutes. So if you solve this, my answer is coming 3.36 kilowatt. Tell me whether all of you are getting this or no. Yeah, very good. Oh, Pushpindra here again, very good. Hello, hi. I remember that all the champions of the crash course. Okay, 3.36 kilowatts, very good. 3.36 kilowatts is the answer. 3.36 kilowatts is the answer. .36 kilowatt is the answer. Yeah, most of you are getting. Okay. Now, see, I told you, 15 minutes back, I want you to focus on this particular problem. The next problem, I want you to give very careful attention. Problem number 7. Next problem, I want you to give very careful attention. And if there is any confusion, please write to me in the chat box. But for next 10 minutes, I want you to pay very, very careful attention. Okay? Read the problem. Read the problem. Very, very good problem. A cylindrical part is warm upset forged. Warm upset, it's a forging operation. Okay, na? It's a forging operation. Ferrous means there is some iron is major impurity element, it's called ferrous alloys. And when iron is not present as a major base metal, it's a non-ferrous alloy. So one other student was asking some question. I think everyone knew. Now you can ask. Okay, and I will answer that one. Okay. Simultaneously, I'm doing this question. I will answer that question also. Whatever Abhimanyu was asking, I think. Open die. The initial diameter is 45 mm and the initial height is 40 mm. Once again, for 10 minutes, have a cool head. Take some water. Take some water, because when we take water, na, we get little peace of mind. Okay, na? So I'm writing the data. Initial diameter is 45. Initial diameter is 45. And initial height is 40 mm. And initial height is 40 mm. So every material, there will be elastic region, there will be elastic region, and there will be plastic region. There will be plastic region. After writing the data, I will answer that question. Okay, na? Please don't write anything in chat box, because I don't want to miss this question. Okay, na? All right. Let us compile the data. The height after forging is 25 mm. HF is 25 mm. Once again, I would like to remind you, all the forging calculations are done on the final dimension of billet. All the forging calculation done on the final dimension of billet. And once again, for 2-3 minutes, you please hear me. It's a very, very important problem. Okay. The coefficient of friction at the die work interface is 0.2. Mu is 0.2. Yield strength of the material is given to you. Yield strength is 285 MPa. I mean, color change. This is 285 MPa. And this flow curve equation is given to you. 600 epsilon raised to power 0.12 MPa. Determine the force in the operation. See, the shape factor is given to you, Kf is equals to, it is not visible, I will write it down. It's a mu d over h. This is a shape factor given to you. So there are two questions here. Determine the force in the operation just as the yield point is reached. And yield strain is point, everybody knows this thing, but still the data is given to you. The strain is 0.2%, meaning 0.002 strain. So when we are forging, how much will be the force experienced by the dies up to yield point? And the second question is, at the completion of forging height, how much is the hammer load? You know, I will summarize this thing. This is the data given to you. Yield point appears at 0.2% means this much is strain. Shape factor is this. Plastic region, this is the equation. Yield point is here. Initial diameter this. Initial height is this. Final height is this. Coefficient of friction is 0.2. Now the question is asking two. Question basically problem is two questions. Number one, as I am forging the material, slowly it is deforming. Slowly it is deforming. So before plastic deformation, now please hear carefully. Don't move, look at here and there, hear me. The moment material begins to deform plastically, what was the load on the dies? The question is asking. But this load is irrelevant to us. This load will not be used anywhere in the hammer press. It's irrelevant, but the question is asking. And the second question is, to complete forging, how much force is required? From hammering from this height to this height, how much force is required? This is a relevant calculation, because that much force we have to apply it on the hammer. This much force will be applied by the hammer. First question is irrelevant practically. It's just a numerical. But second, that much force has to be applied by the forging press to deform the material. But first question, that how much will be the force? How much will be the force up to the elastic limit? That is only theoretical. Always remember, once again, always remember, all the forging calculations are done. All the forging calculations are done based on the final dimension of billet. When the force, how much force is appearing at the time of beginning deformation, it's irrelevant to us. It is not required. It is not required. So now let us see how to do it. Now I will answer some of these questions. No annealing, we will get more toughness. Normalizing, surface will be hard and the core will be tough, because it is having fine grain outside and coarse grain. When the grains are coarse, toughness will be more. That is the answer. ये टाइम है हमारा 11 to 1 डेली क्लास होगी यहाँ पर, ठीक है, संडे को छोड़ के. ओके, सो हमारा, सपोज दिस इज द हैमर. Keep on looking at me before attempting question. Suppose this is our hammer. I mean dies. These are our dies, and this is the work. In today's discussion, two problems I want you to see very carefully. One is this problem, and one problem half an hour back we discussed. These problems should definitely go to your heart. That's what my desire is. Okay, now? So let us say this is the L. And if you see the friction hill, it is like this. Friction hill. Forging friction hill. Okay. And this is sigma naught. This is sigma naught. That is the way friction hill is. That is the way friction hill is. Now, ये क्या हो गया? The forging load is technically an area of this friction hill. Forging load is technically area of the friction hill, and that's how we calculate in the slab method. There is one such problem that I will solve it here. But in the upper bound theorem, when the shape factor is given to you, you know what shape factor tells you? Shape factor gives you how much is the proportion of this. above sigma naught, how much is the proportion of this? So forging load will be shape factor sigma naught into area. Kf is equals to sigma naught, Kf into sigma naught into area. So what shape factor tells you how much is the proportion of this load. This is the upper bound theorem. In slab analysis, we do integration. One such problem is there, we will solve it. So first of all, look at it. If there is any question here, let me know. If there is any question, let me know. Okay, everybody is okay? So now let us attempt the first problem. First problem is, when the material begins to deform plastically, how much was the load? So load will be Kf sigma naught into A. This sigma naught will be the yield point. Area, you know very well, area of hammer. Kf. In the Kf, you know mu. I need the value of diameter. I need the value of h. I need the value of diameter. I need the value of h. So I am moving to the next slide because I have to solve this problem. Because we are in the elastic region, I hope you are attentive, all of you. This in the shape factor, this D and H. In the shape factor, D and H are the diameter and height at the point at which you would like to calculate the forging load. But our first question is only the elastic, na? At the end of elastic point, see, strains are very, very small. If you want, you can calculate D and H, but it will be very, very insignificant difference. So D will be almost 45 and H will be almost 40. Strain is given to you. If you want, you can calculate, but because it's a just, we have surpassed the elastic region, it will be 44.889, something like that. This will be 39 point something. It will be almost same. So now put this D and H value, find out Kf, and after Kf, find out the forging load. Can you give me the answer? Just do it. Can you give me the answer? Can you give me the answer? Do it. So it's a circular billet. Pi by 4 di square hi is equals to pi by 4 df square hf. Correct? That's the way we will do. So this area will be almost initial area. In elastic region, area will be all, but this is the equation, equating volume. So this is the second problem. I want the load for the first one. So this is the volume. Color change कर लेते हैं थोड़ा सा. So volume is nothing but cross section area into height. Let us say initial height. Initial height is 40, na? How much it is the initial height? Yeah, 40. Because see, I'm forging, so these are the dies, and H is the height. So this area is the contact area. Contact area between the hammer and the work. So we are talking about this area, plan area. In other words, let us say this is the 2L. So 2L into W is that area we're talking about. But we don't have to calculate L and all these things. This is the volume of the billet. Elastic region calculations are easy. Is equals to A into H. H is almost 40. So calculate A. Put the value of A here, because Kf yield strength into A will give you the load. How much is the load? How much is the load? Yeah. 494 kilonewton. 494 kilonewton is the load. But which load it is? Which load it is? Upon forging, because forging process will consume time, so the moment metal begins to deform plastically, the moment metal begins to deform plastically, at that point, how much was the load? Is this load. But remember, this load is irrelevant. Only for theoretical purpose. Actually, we want the load required on the dies. So this answer is coming correct. Okay. Okay, na? Okay, very good, very good. Very good. Now, come to the second problem. Second problem is exactly same, second bit. What is the second bit? At the height of 35 mm. This question is, how much is the forging load required from forging from this height to this height? Calculate the diameter, because in KF we need diameter, na? एक और पेज है क्या? हाँ, एक और पेज है. Second problem. So KF is equals to 1 plus 0.4 mu d over h. What is this d? The final diameter. H is 35. So what is the d? Equate the volume. Pi by 4 di square hi is equals to pi by 4 df square hf. Find out df. This df is nothing but the d. So you know d, you know h. Find out kf. And once kf is known, load is nothing but kf sigma naught into a. Now, how to find out sigma naught? How to find out sigma naught? Sigma naught will be nothing but k epsilon raised to power n. Remember one thing, in forging we do not calculate average. In forging we do not calculate average. Other metal forming operations we do calculate average, but forging we don't calculate average. So epsilon, put the value of epsilon, k epsilon raised to power n, find out sigma naught. Do it. I have some calculations here. Epsilon is nothing but ln 40 by 35, because I told you we calculate true strain in the direction of applied load. Applied load is in the forging direction. So epsilon, put the epsilon value of here, you will get the value of sigma naught. And the sigma naught, my answer is coming 471 MPa. Sigma naught is coming 471 MPa. Okay. And this diameter is coming, my calculation. This diameter is coming, my calculation, 48.1. Check whether it is correct or no. Check, all of you. I want to answer from you whether it's correct or no. Or if somebody calculated the final answer also, and that answer is correct. Abhimanyu, Rohit, your answers are correct. But I want you to confirm these things. Once again, in forging we do not calculate average, k epsilon raised to power n over n plus 1. No, because of the shape of stress strain diagram in compression, and the forging is done momentarily. Okay, na? So d is given, area is pi by 4 d square, same, put it here, load, and the load value will come out to be 950.6. 950.6 kilonewton. 950.6 kilonewton. Very good, very good. Very good. The problem is that in the evening, it's a Abhyas. Pushpendra, this Abhyas batch. Abhyas batch is designed in the afternoon only for me, because evening there is somebody other faculty schedule. So schedule cannot be disturbed, because PW is very careful about the schedule. Okay, na? Schedule should be followed. Uh, 950 kilonewton. 950 kilonewton. 950 kilonewton. ठीक है? Yeah, most of you are getting it. Most of you are getting it. अरे कुछ आगे स्पेस नहीं है, चलो यहां मैनेज करते हैं. Okay, is that okay with everyone? Yeah, happy Diwali. Okay, so now have a cool head. See, I will follow this approach. I will follow this approach. I will follow this approach when the shape factor is given to you. But suppose my problem is same, but the shape factor is not given to you. My problem is same, but the shape factor is not given to you. Meaning, di, hi, hf, mu, these values are given to you, and the sigma naught is given to you. Sigma naught we have calculated, na? Sigma naught we have calculated 471 MPa. So only this data is given to you, shape factor is not given to you. Then we will go by the slab analysis. Then we will go by the slab analysis. In exam, that's the way we will do. If the shape factor is not given to you, we will go by the slab analysis. So first of all we calculate RS, whether sticking is there or no. RS, and it will be nothing but R minus H by 2 mu ln 1 by 2 mu. Just I'm quickly glancing at it so that you know. Okay, very good. Go for namaz. Today is Friday. Acha, oh, you are namazi 5 time namazi. Okay. If you put in this formula, RS will come out to be positive. RS will come out to be positive. Sorry, RS will come out to be negative. Sorry, nahi, because my thing is coming negative. So no sticking. So no sticking is taking place in the forging operation. So load will be, because if you see the forging die, if you see the forging die, dr is the strip at an radius r. So forging load will be twice integral 0 to r PR1 2 pi r dr. R is d by 2. D we have calculated previously, and PR1 is nothing but sigma naught e raised to power 2 mu by h r minus r. So you know everything. By this way you will calculate load. Value of this load will be different than other load, because this is the slab analysis and previously was upper bound theorem. Both answers will be different. I will follow the slab analysis, this procedure, when the shape factor is not given to you. If the shape factor is given to you, I will follow this approach. If the shape factor is given to you, if the shape factor is given to you, I will follow this approach. Otherwise, I will follow the slab analysis. So that was the problem, very, very important problem. And I want all of you to focus on that. Okay, na? Okay, all right. So now, see the next problem. In 10 minutes, we will finish, because now the problems are easy. Now the problems are easy. So in between, I have given some difficult problems to all of you. Okay. Now things are easy. A strip of lead with initial dimension is forced between the two flat dies to a final size of, what I told you, all the forging calculations are done. Based on the final dimension of a lead. Based on the, नहीं टफ नहीं है, easy है. Calculation थोड़ा सा आप देखो. All of you should put this definite integral in calculator. Calculator will give you answer. But anyway, here in the Abhyas, I am showing you the concept. In the gate, question may appear from the concept. Okay, na? For example, 2 years back the concept was there, na? This was the concept. Sigma x px. Sigma x plus px is equals to sigma naught. Based on that, because it's an intermediate stage in proof, from here the problem appeared in gate. So I'm teaching the concept, okay na? Ha. So all the forging calculations are done based on the final dimension of a lead. So this one, the dimension that decreases is a height. The dimension that increases is length 2L, and the dimension that doesn't change is the width. All the forging calculations are done on the final dimension of a lead. The dimension that decreases is the height, and the dimension that increases is length 2L, because here we say na, here we say like this is L, and then we take the element, correct na? So it's a 2L, we take 2L, okay na? And the dimension that doesn't change is W. Coefficient of friction is 0.25. And the average flow stress is given to you as 7 MPa. So you have to calculate the forging load. See, this problem I will not solve completely. I will give you the procedure. Then you can just put the definite integral, you will get the answer. Just I want to tell you the procedure, okay na? So any forging operation calculations are done based on the final dimension of a lead. Now to begin with, we have to know whether sticking is taking place in the forging operation. That is the first one we have to check. So it's a rectangular forging. So sticking length xs is L minus h by 2 mu ln 1 by 2 mu. So you know h, you know L, you know mu. If you put everything here, so I'm just quickly glancing it over it, because I don't want to get too much into the calculation now, because we have already done the calculation sufficiently. This xs is 39.68. You know what is the meaning of that? 39.6. So this will be the sticking region, and this will be the slipping region. Slipping and the slipping here. So this L is basically, I have calculated this. L is 48. This L is 48. So from 0 to 39.6 there is a sticking, and 39.6 to 48, there is a slipping. So now the forging load will be the area of this friction hill. It's the area of the friction hill like this. The area of this friction hill is the forging load. Area of the friction hill is forging load. So forging load will be nothing but twice, because I am integrating on one side, extending on both the side. Integral 0 to 39.6 px2 dxw plus 39.6 to 48 px1 w dx. Okay, it's a little complicated, little cumbersome calculation. Px1 is nothing but 2k dash e raised to power 2 mu b h l minus x, and px2 is nothing but k dash by mu plus 2k dash by h xs minus x. This type of calculation may not appear in grade, but I am giving the procedure. Suppose something pops up. So that is the reason I am not dwelling too much on this. One. Last problem is the question asked. One of you asked basically. I forgot the name. Last question for the day. One student asked this question. Maybe some test series kind of stuff and all that. So he was asking, sir, can you solve this question in the Abhyas one? I said definitely. So this question, I think somewhere test series or some exam he must have seen. So that's the reason I have written student's question. So for him I am telling, I think it is beneficial for all of you, because there are some popular doubts. Some popular doubts are very, very important. ठीक है ना? So now a cylindrical billet of 10 millimeter diameter is forged from 50 millimeter height to 40 millimeter height. Initial diameter is 10 millimeter. Flow stresses are, forget about the temperature. Flow stresses are 80 MPa. Sigma naught is 80 MPa. Find the work of deformation. First of all, find out the work of deformation. If it 10 kilonewton drop hammer is 10 kilonewton to complete the reduction in one blow, what will be the height of fall? Read the question once. Before I start solving, please read the question. It's a very good question. Of course, I answered him, but I want all of you to learn this question. Read the question. Read the question. It's an easy one. It's a very easy one. Now, what is the funda I told you? I think this student, some teacher or some book must have solved it, and there was some wrong question. The wrong solution for that. I explained to him how to handle it. See, in forging, all the calculations are done on the final dimension of billet. We will never take the average anywhere. All the calculations are done on the final dimension of billet. So final force will be sigma naught into the final area pi by 4 d2 square. How to calculate d2? Equate the area. Pi by 4 d1 square h1 is equals to pi by 4 d2 square h2. From here you will get the area. Put it here. You will get the force. And once you get the force, work done will be nothing but force into displacement. How much is the displacement? h1 minus h2. Because this is the displacement, 10 millimeter. Give me the work done. Quickly give me the work done. Quickly give me the work done. Quickly give me the work done. Chat box, give me the work done. Quickly give me the work done. Value of work done. Quickly. Quickly give me the value of work done. I have the solution. Okay, na? I have the solution. All the forging calculations will be done based on the final dimension of billet. No, I think my answer is slightly different. I don't know why. Ashok Dahiya. My answer is coming 7850 joule. 7850 joule. Because force into displacement. Yeah. No, I think 7850 joule it is coming for me. 7850 joule is coming for me. 7850 joule is coming. I ask the students to basically answer. If you keep on writing the same thing, how the other? This is not good actually. Okay, no? 7850 joule. Now, just 2 minutes. Just 2 minutes. Achha, height in mm. So height height in mm is easy, na? From 50 mm to 40 mm, 10 millimeter. Now, a dead weight is allowed to fall over workpiece. And what strength of materials tells you? What strength of materials tells you? What strength of materials tells you? Impact loads are twice to that of gradually applied load. Impact loads are twice to gradually applied load. So from what height the hammer should fall? So we need 7850 joule energy because it's the impact load. Impact loads are twice to that of gradually applied load, and the hammer provides 10 raised to power 4. So from what height it has to be dropped? That is the way we calculate the height. That is the way we calculate the height, and that answer will be 392.5 mm. 392.5 mm. So that was the answer. Okay, very good. That was the answer. So it was a good question. Some student asked. That's the reason I have incorporated in my discussion. So this was the first lecture of Abhyas forming. Tomorrow I am going to discuss rolling and the sheet metal forming. Some beautiful questions of rolling and the sheet metal forming. After that, two lectures I will take questions on metrology, one lecture on welding, and one lecture on automation. Okay, na? Yeah, sudden load is twice. Correct, na? That is the reason I have multiplied by 2. Sudden loads are twice. That is the reason I have multiplied by 2. Okay, na? So that was today's lecture. So see you tomorrow at 11 AM on forming lecture 2 Abhyas. Thank you very much. Good afternoon to all of you. See you tomorrow at 11 AM.